Okay. What I'm going to present today is the physicochemical properties and sensory evaluation of energy bar made from various protein sources. I have prepared two papers. First, I would like to start by summarizing the energy bar. Energy bar often referred to as nutrition bar or high protein bar, but today I will refer to both as energy bar. Energy bar is a convenient and healthy ready-to-eat food that supplies balanced nutrients which contain protein, fat, minerals, vitamin, and carbohydrate. First paper is this. They want to produce energy bar using tempeh and observe physicochemical properties and sensory tests. Let's explore together what is tempeh. Tempeh is a traditional fermented soy food prepared from soaked and cooked soybean by salt-free aerobic fermentation using Rhizopus oligosporus. Firstly, prepared tempeh is a cake-like substance that is fully cooked and filled with white mycelium with a clean yeast odor. Tempeh is considered as a good source of protein, vitamin, and other bioactive beneficial substances. In this paper, tempeh was prepared using Cannabalia ensiformis. First, beans were washed and soaked in clean tap water at room temperature for 48 hours, and the soaking water was changed 5 times and then boiled for 30 minutes. This was followed the dehuling to remove skin from the cotylene manually and another boiling for 30 minutes. Subsequently, drained and air dried. Then 0.02 gram of Rhizopus malt was inoculated for every 100 gram cooked beans and packed into plastic bag. Then incubated for 36 hours at 32 Celsius. The prepared tempeh was kept in 4 Celsius prior to further uses. All the ingredients were weighed based on the formulation present in table. The sliced tempeh was then roasted in the oven for 1 hour at 100 Celsius. The tempeh was then ground to small size using mortar and pestle. Prior to the mixing process, almonds were roasted for 10 minutes in the oven, while oats also were baked for 10 minutes. All the ingredients were cut to small size before mixing in the bowl. Brown sugar, honey, and butter were heated at low temperature and then mixed with roasted ingredients. The prepared mixture was then pressed to produce the rectangular shape in the mold. The energy bar was then kept in the chiller prior to further analysis. This table revealed that the L value of the formulation was also increased with the increasing amount of tempeh, suggesting the influence of tempeh on the lightness of energy bar or color. The energy bar's red color may be attributed to the amount of almond in the formulation as well as the presence of other almond ingredients. For the other tests, the p-value was identical, suggesting that the butter mixture might be other ingredients that could have led to an increased value in yellowness of energy bar. The energy bar color are quite similar to each formulation due to the color of each ingredient, while the amount of tempeh and amount of almond gives a small effect to the bar. This table shows that the hardness of energy bar. In general, the low hardness of the formulation was observed when a low amount of tempeh was incorporated into the formulation. This could mean that when the protein are used, the bar may have a better or worse texture than expected. In addition, all formulation shows a somewhat similar spectrality value, indicating that the tempeh did not have an analysis effect on the texture profile value. However, due to the low amount of tempeh incorporated in the formulation, low spectrality was observed in the analysis. Next is chemical composition. The highest moisture content of energy bar was formulation E. It shows that increasing the amount of tempeh in the formulation, thereafter increase the amount of moisture content in the energy bar. The highest ash content of energy bar was recorded in formulation A, while the lowest percentage of ash content was found in the control sample. This shows that the addition of tempeh in the formulation reduced the ash content in energy bar. This may be due to the uses of the nut, where the almond itself contains higher ash content with the 3.13%. The ash content in this study could be traced to the nut used, which could be considered as origin when minerals such as calcium, iron, and magnesium. The highest protein content was found in formulation E, while the lowest protein content was found in formulation B. The higher value of protein contents in energy bar may be due to the utilization of tempeh in the energy bar product, which contains higher protein compared to almond. In the fiber contents that there was no significant difference. The observed increase in crude fiber could be attributed to the presence of tempeh. The results also show that there was no significant difference in carbohydrate content between all formulations. The carbohydrate source might be from the uses of brown sugar and honey in the production of energy bar. Next table shows that there were significant difference in the total calorie value between all formulations. Control sample contains significantly the highest calorie contents, while formulation E exhibited the lowest calorie value. The decreasing trend of calorie value of energy bar could be due to the reduced amount of cereal and nut used in the bar. And we can see the mineral contents that present in 5 formulations of energy bar and control. The data shows the mineral level in the energy bar. This shows that ion level are not affected by the increasing amount of tempeh and decreasing amount of almond. The mineral content in the energy bar was typically lowered as the amount of tempeh increased. This resulted in attributed to the reduction in ash content. According to this result, among the sample with tempeh, sample A had the most favorable sensory evaluation outcomes. The color, odor, hardness, spectrality, and taste. The panelists select the most agreed formulation A compared to other formulations. This might be due to the different percentage of tempeh in the formulation that affect the characteristics of the energy bar. This study exhibits that tempeh may serve an excellent candidate for the development of alternative energy bar using rich protein low material, which have been underexploited. The formulation A was mostly accepted by the panelists. This study showed that tempeh can be used in energy bar production, thereby encouraging its use in the food industry. Next paper title is the effect of protein source of the physicochemical nutritional properties and microstructure of high protein bar intended for physically active people. The purpose of this study was to investigate the effect of protein source on selected physicochemical, nutritional, and structural parameter or high protein. They use whey, soy, pea, rice, wheat, whole agar, sunflower, hemp, pumpkin protein for protein concentrate. Protein concentrate with maltodextrin and aroma were placed in the bowl and mixed using the mixer for 1 minute at 190 rpm. Barely melt extract was dissolved in water in a separate laboratory vessel. In another vessel, soy lecithin and rapeseed oil were combined. Glucose syrup was heat to 80 Celsius and then poured into dry ingredient placed in the mixed bowl. The remaining ingredients present earlier were added simultaneously after pouring the syrup. The best prepared in this way was mixed for 5 minutes at 365 rpm using an or end. Finished processed energy bar beds were laid onto the conveyor belt and pulled out by forming roller to the height of 15 millimeters. The height adjusted bar base was then full and temperature of 10 for 15 minutes. The chilled bar base was subjected to longitudinally cutting. The cup mass was finally cut transversely into individual. The bar prepared in this way, which were to be coated with chocolate, were transferred to the coating machine and they were covered with chocolate. Chocolate coated bar were cooled to a temperature of 10 Celsius for 15 minutes. The final energy bar were packed in high barrier foil. The sample was stored at room temperature for 3 weeks in a plastic container. After the storage period, the sample were tested. The influence of different proteins on hardness, fracturability, adhesiveness, and cohesiveness of obtained processed energy bar with chocolate coating is present in table. Significant differences were observed. The bar made of sea agar protein has the highest hardness, while the lowest hardness characterized bar made from rice protein in the sample. Sensory hardness can be defined as the force necessary to compress the energy bar with the roller. Fracturability is the tendency of material to fracture, crumble, crack, shatter, or fail upon the application of relative small amount of force. Adhesiveness is the work necessary to overcome to attract force between the surface of product and the surface of material, with the products come in contact. Cohesiveness is the tendency of product to cohere or stick together. Generally, hardness of energy bar is quite high and increased with the addition of protein. A certain regularly can be dosed for bar made of whey protein. Relatively low value of hardness parameter translate into high value of adhesiveness and cohesiveness, and simultaneously low level of reactivity. A complete different situation can be seen for agar protein. Despite the high hardness of the bar made of type of protein, high value of adhesiveness and cohesiveness parameter, as well as very low reactivity value were observed in the chocolate protein bar. Based on the analysis of result in picture of microstructure of bar, it can be assumed that protein with large particle size used in the production of high protein bar cause a significant increase in the hardness of the final product. According to this rate, fine-grained protein have much lower tendency to form hard structure during the storage process and allow for the creation of delicate and soft product structure. The highest water activity value characterized bar made of sunflower protein bar made of sea agar, pea, and soybean protein have water activity lower than 0.65, which guarantee the stability of samples during storage and inhibition of microbial growth. Other bar made of hemp, rice, and sunflower had water activity above 0.65. Therefore, it can be suggested that they should be stored in conditions of lower temperature. Increased water activity may indicate movement of water molecule from the intermediate phase, where they act as plasticizer to the bulk phase. Protein included in the bar that exceeded 0.65 water activity value had a fairly high degrees of fragmentation and originated from various plant species, which could also have significant impact on this parameter. Often for people consuming the high protein product, nutritional and pro-health value are important. The obtained result of the contents of amino acid in the test bar present in figure show significant difference between the contents of individual amino acid in different type of protein. The largest deviation can be seen in the proline contents for bar made of WHP protein. It can be assumed that such a high contents of endogenous amino acid proline may be caused by naturally high contents of proline in wheat grain. Proline is an important amino acid for physically active people and athletes, as it participates in the formulation of sensory structure in collagen. Exogenous amino acids are essential and human body cannot synthesize them from scratch at the rate commensurate with their need. Therefore, it is necessary to provide them to the body in properly balanced diet. Out of total 21 amino acids, 9 are considered essential, including phenylalanine, valine, threonine, tryptophan, methionine, leucine, isoleucine, lysine, and histidine. Proteins found in animal sources such as meat, fish, egg, and yogurt provide all 9 indispensable amino acids, and hence they were referred to as complete protein. Proteins found in plant, legume, grain, nuts, and vegetable tend to deficient in one or more of indispensable amino acids and are called incomplete protein. It can be assumed that despite the high contents of essential amino acid in the WPC reference sample, alternative source of plant-derived protein may be an attractive proportion for people who do not want or cannot consume protein of animal origin. It was observed that bar made of soy, rice, and pea protein show significant enrichment of the entire spectrum of amino acids, among which essential amino acids, which have been determined in significant amount as for protein of plant origin, deserve special attention. The high content of essential amino acid in soybean and rice protein isolate. Therefore, it can be assumed that this protein may become more and more popular, especially among vegan and vegetarian, and allow essential amino acid in such diet to be satisfied. Result of sensory evaluation of the test energy bar are present in figure. The highest source during the analysis were obtained of bar made of WPC and PAP protein. The evaluator appreciate the external appearance, color, and test sensation the most in highest rate bar. The conducted research showed the protein of plant origin can be successfully used in the food industry as the alternative to WPC protein. However, it is not possible to clearly indicate which type of protein is the best option. Nevertheless, the high contents of exogenous amino acid or the technological utility result from the texture parameter of bar made of RPC, SPI, and PAP protein speak for this source. More research is needed on storage trial, microbiological test, and examining the effect of changing other components in the recipe that may affect the parameter important for the food industry. This is reference. Before concluding my present, I'd like to mention one more things. We will be conducting a sensory evaluation of sweet potato protein bar. We've developed with collaboration with Hanul Company in next Monday. We require your participation. Thank you.